Hi, my name is Pritesh Rajaguru, and this is Physics 2212, Lab 3, Magnetic Fields and Bar Magnets. So the purpose of this lab is to visualize magnetic fields via bar magnets, and this will show us how distance affects magnitude in the real world. To do this, we're going to be using distance dependence, which shows how bar magnets, how their magnitude falls off as distance increases, and we're going to be using Biot-Savart law for a magnetic dipole. The steps of this lab is to place a meter stick in axis with the bar magnet you have chosen and to make sure that you compensate for the magnetic north by finding it to cancel it out. And then using the magnetometer app, you have to find the magnetic field along the meter stick. You have to do this for both in axis and 45-degree angle from the bar magnet. This you have to record onto your Excel sheet and also mark each point that you find it at. So recording your data down, this is roughly what it should look like, at least for on axis, in which the graph shows us ln of bx versus ln of r. The slope of this function is the distance dependence, which is negative 2.8, and ln of k equals to negative 14.54, which just k from that equals about 4.87 e to the negative 7. This will be useful in order to find the magnetic moment for the bar magnets, which ends up being 2.44. So this is my off-axis measurement data via 45 degrees, and as you can see, the experimental data is nowhere near the same as the glow strip data. This is because in the glow strip one, the only one being considered is the bar magnet, the only magnetic field, while in the experiment, we have to take into consideration Earth's magnetic field. Even though we did compensate for it, it is still active. So this is my glow strip code. As you can see, the two on the edges represent the observation points and their vectors. Each observation point for the x values are coded in red, and the ones for the y values are coded in blue for uh, each individual vector. And the one in the middle is the Biot-Savart law, which is to help find the magnetic moment for the bar magnets. So this is the glow script model via the code in the previous slide. So the red arrows are the ones that are on axis with the bar magnet, while the blue ones are the ones that are perpendicular towards the bar magnet in the y direction. The green one is the vector of the 45-degree angle one, which we can find from here has a distance about 0.236 meters away from the bar magnet, and it has a vector of 9.26116 e to the power of negative 6, 2.77835 e to the power of negative 5, and it has no z direction. So time for some what if questions for the conclusion. So what if you hadn't orientated your experiment to compensate for the magnetic north and had instead laid out your meter stick at some indeterminate angle with respect to Earth's magnetic field? How would your results have changed? If this happened, we wouldn't be able to count Earth's magnetic field to be negligible, and as a result, our results would be way more skewed than they already are. And what if you were to stick two identical magnets together ends to end and run the experiment again? Well, if this happened, the magnetic field would increase while the distance would decrease as well. I thank you so much for watching this, and I hope you have a wonderful day.